TechEd 2004, my goodness. Look at all the nice people who showed up. My name's Don Box. That's Doug Purdy. We work together in the distributed systems group at the firm. And we're going to spend an hour plus with you folks talking about the problems we're working on, how we think about them. Maybe that'll help you think about them too, or at least you'll understand where we're coming from when we do this stuff. There's a lot of, it's kind of interesting to watch how the industry works. You know, 2000, 2001, 2002, the majority of the ink in the trade press was dedicated to web services. You probably noticed a trend sometime in 2002, and it's certainly in full swing now. A lot of folks are focused on this notion of service orientation, or more popularly called service-oriented architecture, or SOA. And what Doug and I are going to try and do is put that stuff into context in terms of, you know, what you as a Windows developer or you as a .NET developer need to think about when you use the various technologies we give you to do these kinds of programming tasks. And you know, hopefully it'll be of some use to you. So why don't we go ahead and get started. There's a whole spectrum of talks related to the stuff that our team works on. This is the initial session, which kind of just sets the tone. There's going to be tons of drill down. There's any number of talks there that are extremely interesting, and I don't want to alienate some of my friends and call out one over the other.
You can talk about my talks, though.
Okay, one of these talks is Doug's talk, and I can't imagine that one not being fantastic.
I can, but that's okay.
Yeah, okay. So I really suggest if you want to see more and more nuts and bolts, we'll do a very small amount of that given the fact we don't have much time and we have a lot of surface area to cover. There's plenty of information, and most folks on the team are going to be hanging around TechEd most of the week. And by all means, corner us and tell us what you hate about our stuff, tell us what you like about our stuff. One thing that I should mention, the name of the group is the Distributed Systems Group. We own a whole bunch of stuff. So we're responsible for technologies as humble as COM to stuff that's as ambitious as Indigo and everywhere in between. And a lot of us have been working on that technology for over a decade. And so we kind of work on making programs work together. A good friend of mine, Pat Helland, has an acronym for the stuff my group does, which is HST, which politely is hooking stuff together. And there's more colorful interpretations. By the way, I should tell you, I have the flu, so when we do the walking around and you pass me around like when I do the
stage diving?
The stage diving.
Yes.
Be careful and wash your hands after you touch me. So, as any good session must do, we have to have a Q&A where we actually figure out, did we answer their questions? What did we not talk about that you wanted to know? So what we're going to do is, instead of doing this at the end, which means this is the queue to get in the front of the bathroom queue, right? We're going to start this session with the Q&A.
Well, at least the Q part.
At least the Q part and probably a couple of A's. So right now would be a fantastic time to get up there and seed this with some questions. And what I'm going to do is take notes.
There's microphones here at every aisle.
There are microphones here.
Please come up, ask questions.
And I promise there's a T-shirt in there for you somewhere.
Becky,
yes.
Are the microphones on? This came as a shock to our wonderful AV folks, so we apologize.
Go ahead. That's an excellent question.
So the question is, where are we going in terms of the direction of developing COM components?
We'll get there.
That's great. I think we have a whole slide on that, Don.
Yeah, we do.
Over
Any
here.
other questions? Yes. Great question. I want to know that too.
This is a great opportunity for us to do strategic decision making on the fly. And is Becky in the audience? I guess she'll have to abide by those decisions.
Yes. Yes, sir. Where's the T-shirt? Where's the T-shirt?
Well, don't you believe us? Don't you take it on faith?
What's the future of Dime?
Great question. Okay. Okay, good question. What's the level of support we'll have for SAML? The non.NET web services? Okay. I think, was that the same question you were about to ask in the back? Security question, all right. Okay, good question. So we have two questions about Dime. Another question here.
We write a lot of Windows services. How do you talk about SOAP from Windows service?
Okay, great question. How do you talk SOAP from a Windows service? Okay. What is the technology to replace COM+ over the long term? Okay.
I'm wondering about the philosophy of these web services. Like, is there a way I'm trying to connect to cell phones to audio?
Sure. So the question there is payload size utilizing web services. I think it's verbose because Don and I work on it, and we like to talk a lot.
You're talking about service architecture. What is the plan for the public for storing policies, applications, directory, and so forth? So in other words, how will you find services and how will policy documents be communicated?
So discovery as well as determining policy at runtime. Okay. Any other questions at all? Don't be shy. Yes. Great question. Do we still need to be plumbers to do web services security? I'm sorry, one more time? So what is the MSMQ equivalent for COM+? Okay. How does EIF fit into SOA? Okay. Oh, yes. EIF. The question here was a rumor about MSMQ going away. You're in the right talk.
You're in the right talk.
The question is, let's clear up the story about how we connect things together. Question over here. Absolutely. What is the migration path to SO? Okay, strategies for native to manage interop. Question in the back, and we'll come up front. How you doing, Ted?
Good question, Ted.
We didn't seed him, I promise, yes. I'm sorry, one more time? Any application blocks for web services? Or SO? Okay. Okay. Application blocks for SO, and we'll take two more questions.
I was just curious if you could address things around remoting, like global events, and how we get distributed across.
Okay, so the question is the role of .NET remoting and how we distributed management across app domains? I'm sorry? Remoting of events. Okay, remoting of events. We'll talk about that. All right, one more question. Who wants the last question? I'm lost. Ah, there you are.
Regarding security, regarding authentication and authorization, what about any other attacks through the channels or any of the other security type stuff? Do you looking for filtering content or what kind of things are happening on the web service channel?
All right. And that I think we can go away now. We've got all the questions. We
Yeah.
can go answer them and come back in a year.
Cool.
That humor didn't go over well.
That's fine. By the way, thanks to Becky Diaz, we have T-shirts. So those of you who ask questions can come up afterwards and get the T-shirts. Should we look at one?
Yeah, we should look at it. Let's see. Because we might want to.
Well, I remember there were so many good shirt ideas.
There were a lot of good shirt
And
ideas.
I have no idea what we actually went with. So let's see.
Let's take,
The back says "Wissy launch," and then the front says "I'm secure." Great.
it has a pipe.
Wow, very nice.
Is that okay? I was going to make some snide. Forget it.
Great.
So come up after if you ask a question. We have T-shirts. You're on the honor system, and we trust you.
Cool.
Because security is all about trust.
Oh man. This is an excellent set of questions. I think we'll nail most of them.
Yes.
And we'll make sure that when we get towards the end, we'll come back around and get them all. But I think we'll nail a bunch of them in the second half of the talk. Cool. Well, thanks for those questions. Hold on while I cough one last time.
He's been doing this all week.
There we go.
In fact, my children are sick because of you, Don.
I know. The world is sick because of me.
So as Don said at the beginning of the talk, we want to provide you a little motivation about why SO exists, about why Microsoft is so convinced and so compelled to deliver SO solutions. And what you see on the screen here is a fundamental truth that our team believes should drive the way that we develop architectures and infrastructure. And we only recently came to this realization. The realization is that there is one program and it's still being written. I want you to think about that for just a second. Just stop and think about it. There is only one program and it is still being written. This is the reason our group exists. This is the reason we're working on technologies like Indigo. It's the reason that we do protocols like WS Star, and it's the reason that we do things like Wizzy. Because we fundamentally understand that there is only one program, and it's still being written. And SO is all about acknowledging that fact, and then having technologies and having design architectures that allow us to add things or to utilize things in that one program. And to acknowledge that it's not complete yet. It's still being worked on. It began back in the 40s. It's going to continue up until today. It's going to continue after my children decide that they're going to start the program. If they do, hopefully.
Yes.
I think they should. That way I can retire early. But the key thing here is everything that you work on is part of one fundamental program. And you're just writing a module, you're writing a class, or you're writing a service that will participate in that one program. And you provide functionality to other pieces of that one program. And if you bear that in mind, then it becomes very, very, very clear that SO adds tremendous value to the way that you think about the distributed space. And I think it's very instructive to take a look back in history, computer science history, and think about before we came to this realization, at least before the distributed systems group at Microsoft came to this realization. I sort of divide these up into BP and AP, before program and after program, sort of that moment in time where we realized that there was only one program in the world, and it was still evolving. It was still continuing to being developed. And if you look at the technologies that were before we came to that realization, technologies like DCOM, like COM, even before that with DCE, RPC, you saw technologies that were trying to link things together, but they hadn't adopted or hadn't realized this fundamental truth of only one program. They were all about homogeneous architectures. They didn't bear in mind the fact that this program is evolving, and one bit of it may be on a mainframe, and another bit of it may be on some microcomputers, or another bit of it might be in mini computers. Really think about your enterprises. Think about the software that you sell in enterprises if you're an ISV or if you're a consultant. Think about the enterprise computing infrastructure as one program, and then it becomes fundamentally true. This tenet, I don't want to call it a tenet, but this particular idea becomes very, very clear that that's what's going on inside of an enterprise. And that's what's going on throughout the internet as well. And so if you look before program and you look at the homogeneous technologies that you have there, and then if you see, at least in terms of the technologies that Microsoft has adopted and that we start to push forward, look at what has evolved after we've come to this realization. One, WS star, right? All those web services protocols that really realize that we're writing all these different autonomous services that communicate and participate in one program. Look at Indigo, look at ASMX, look at Wizzy. All of those things are all about acknowledging that there's one program and that it's going to continue to evolve. And these are mechanisms and facilities to make that happen. And this is the most, if you walk out of here with anything, this is probably the most profound thing that you should understand. And this is the core fundamental reason we're doing what we're doing at Microsoft. And this is the driver. This is the reason for SO. SO acknowledges this, and it also enables it.
So, life changes when you realize there's only one program. I know when I came to this realization, and Doug was with me and saw it, before I did actually. It's pretty profound. When Doug and I kind of came to this conclusion, we wanted to measure, are we right? I mean, how could this be? And really the most interesting piece of evidence that there's only one program is the existence of a loader, right? The fact that we've got a loader that allows the program to grow, right? When you build programs, when you build code, when you think about how it's going to work, you have some notion of the amount of code that's going to be around, that's going to be deployed with you. But ultimately, the fact that that code has to be integrated into another environment, like an operating system or a runtime or an app server or a container, right? All of those ideas are based on this notion of having a loader. And if you look at all of the technologies that people use in this space, things like COM, DCOM, remoting, ASMX, Indigo, right? We should just make a big, giant, long acronym for all of that stuff. They all start with this notion of a loader. Someone asked earlier on in the Q part of the talk, right? What's going on with policy and discovery and metadata and directories? What are you guys doing about that? The reason that turns out to be an exceedingly important question, and a question that, quite honestly, we have a lot more work to do on, is because one of the most important aspects of having this program work is the fact that we have a dynamic, extensible loader. We have the ability to add code to the program as it runs. Another really interesting observation, when you realize that there's only one program, is that we can't reboot it. We have no ability to stop the program and do anything. The program can't stop. We can take parts of it offline. We can replace parts of it over time, but ultimately, the aggregate computation that's represented by this program isn't ever going to stop. And it's very interesting if you look at the various technologies we ship today, that we've shipped in the past, and that we're going to ship in the future, and that other vendors are going to ship as well. I mean, I have no illusions that all of the program is composed of Microsoft code. It's quite the contrary, right? It's mostly other people's code that's running in that program. We just have a small sliver of it. Granted, it's a profitable sliver, but it's a sliver nonetheless. I need the ability to bring that program to life, which has already happened, let pieces come online, and let pieces go away, and getting new code introduced into the system is important. Now, if you look at technologies that ignore this, technologies that think they can change, something interesting happens. They fail. Darwin was a software engineer. Darwin is alive and well and overseeing this program. And what happens is natural selection keeps the program running. Fundamentally, people have ideas. Human beings bring what they can to writing this program together, right? You write code, she writes code, he writes code over there. Some of it succeeds, some of it kind of falls away. Why? Because natural selection is taking its course. And one of the most interesting aspects of this is the realization that you can't actually change the way the program works. This aggregate program is running. You can introduce code into the system. You can try and remove code from the system. Removing it's very hard. Adding code is easy, right? A lot of my job as an architect at Microsoft is trying to get code out before we ship it, right? I'm trying not to invent new features. I'm trying to kill, all these redundant ones we have, right? Because I know it's really, really hard to get it out once you have it out there, right? The fact that we have to have half of this talk dedicated to which of the N of these technologies should I use speaks to what happens when you let things into the system. It's very hard to get them out. But ultimately, there's very, very little choice any of us have in the way this program operates. The program will survive independent of any of us. The program's going to outlive us all, right? What's really interesting about this is we had an opportunity to see the program stop, right? The program started in the 40s and kind of grew and got bigger, and then the internet happened. We had global connectivity, and it became more obvious to some people that we had one program. It only became obvious to me recently. We had a chance, though, for the program to stop. People were frightened to death that the program would stop executing. What would happen? Lights wouldn't work, street lamps would stop working, traffic collisions, most of the cars wouldn't work anymore if the program didn't work. Right? It'd be bad. And what, of course, was that one opportunity, the one chance we had to stop the program and start over again? Y2K. Fantastic thing for many of us. Many people drive very expensive cars, live in very big houses because of Y2K, right? And we all wish those days would come back, I know, right? But they're not going to. The program proved to us that it was resilient enough to keep going, even though we had to replace some of the code in the program as it went along. But the observation that choice is something you have no choice about how the program works. People think, I have a choice about Java, right? People think, I could be a Java programmer, and that will be enough, right? Sun had a wonderful vision, right? A beautiful, beautiful, beautiful vision that I personally, prior to working at the firm, was just so in love with. One language to bind them all. One runtime to bind them all. That what we're going to do is make the entire world based on the JVM, and that will be the grand unification of the program. And the program will be so much better because of it. And what happened? It didn't work. What happened was .NET, right? What happened was a lot of things. Actually, more interestingly is what happened was PHP. What happened was PHP, Python, Perl, and yeah, this little .NET thing that we have going on the side. But ultimately, people saw not only were there other ideas that might be worth investigating, that might make the program better, or at least my little neighborhood in the program better, right? Maybe I need a little more dynamism than I get with the JVM, or certainly with the Java language. But more importantly, the premise that failed with Java was the assumption that you could change everything. You can't change the program. You have a small amount of control over your little neighborhood. And that's a very small amount of control often as well. Most of you get paid to program. Most of you who program get paid to program. The person who pays you has some aesthetic, granted it may be completely crazy, that wants you to make, that's basically making all kinds of choices for you. And even those choices are somewhat limited. Right? How many operating systems do you really have to choose from? How many? The world can't tolerate 100 different ones actively being developed on. right? There aren't that many operating systems that people have to choose from. There's not that many development platforms, quite honestly. It's kind of sad. It'd be nice if there were more, right? But what we have is what we have. The best you can do is make your neighborhood better. The best you can do is to take your little corner of this program and make reasonable decisions and try and make sure that you're not going to regret those decisions 5 years down the path. Now, this whole notion of service orientation, right? If those of you who came to the PDC last year and saw the Indigo talks, we made a big deal about service orientation being kind of the metaphor that we're using when we build this thing called Indigo. And the idea is what we're trying to do is acknowledge the fact that there's one program and acknowledge the fact that we can't change it all. And what happened was we observed from watching what succeeded and failed in all of these technologies we've been living with for the past 10 years. And we said, there are these 4 tenets, there are these 4 observations that when we hewed to them, when we acknowledged them, when we designed to these 4 tenets, the technology thrived. The technology not only was used through a broader spectrum of the program, but it made the program in the aggregate better. Because it was not only maybe easier to develop, and I got news for you, some of the stuff we did made it kind of hard to develop, but at least that made it easier to keep running, or it made it easier to manage, or it made it easier to secure. And so, really, these 4 tenets of service orientation are the immune system of the program. These are the guiding principles that if we watch them and acknowledge them and design around them, we have a chance of making our corner of the program better, and quite honestly, maybe making our corner a little bit bigger. Maybe making our corner of the program a little bit more useful to the rest of the world. And what are these 4 tenets? Really, really simple. Tenet number 1, boundaries are explicit. My neighborhood, your neighborhood, we're going to need a fence, and we'll see that in a second. Number 2, services are autonomous. Right? The notion that I could actually version something in COM. I mean, COM, really, this was a very, very important observation in COM. We used to make this statement in COM that said, interfaces are immutable. Right? We used to define COM interfaces, assign them a strong name, and we used to say we can never change them. And in fact, we could change them. Right? Many people in this room who programmed back in the COM era knew that you could actually change the interface. But pragmatically, we had something called the 2-cubicle rule. And the way this worked was, in COM, you could actually change the interface safely if the only people using it were no more than 2 cubicles away from your office. Because the idea would be you would peek out over the cubicle barrier and inform everyone who had taken a dependency on this interface, we are now changing it, please sync to the source code control system, or here's the floppy disk with the new interface definition, and it's okay, because I can manage that. Right? When I'm in my own neighborhood, I have a little bit more control than I have out in the real world, right? I have a chance, like, you know, if you look at politics, I think I might be able to influence, just maybe, who gets on the Yarrow Point City Council, right? I live in a little neighborhood in Seattle, and we have a little city council, and I might just maybe be able to get somebody up there so I can get a better sidewalk. Or I can get, you know, some new service that I need from the municipality. I don't think I can make Ralph Nader president. I really think no matter how hard I try and wish and just really wish it was true, oh yes, of course he's right, of course he's right.
You could move to Florida.
I could move to Florida and influence other things, you're right. But in general, it's very, very hard to have broad scope. And so this notion that services are autonomous is about acknowledging the fact that once I deploy code into this program, once I have my code out there, I may not get to change it. I may get to change a couple of deployments of it, but honestly, there are going to be deployments with a V1 piece of code, and I'm in all likelihood not going to be able to chase them all down and kill them. So the fact that I've got these services out there that are autonomous, that I can't control, is a very, very, very important observation in this whole service-oriented world. Right? If you think about the very obvious analogy is, grant me the courage to change the parts of the program that I can change. Grant me the patience to accept the parts of the program I can't change. And of course, the wisdom to know the difference. Well, I'm going to give you a big piece of wisdom. You can't change much in the program, right? You're going to need a lot of patience because there's going to be a lot of parts of the program that are ugly, icky, written by people who aren't good programmers, right? Who aren't even programmers, who are failed journalists and MBAs, who thought they'd get into programming in the 90s because it was this big thing. Those guys wrote a lot of code that we're going to be living with 15 years. They've all moved on to real estate, right? And we're here to clean up that mess. So, boundaries are explicit, services are autonomous, share schema and contract, not class. Tenet number 3, share schema and contract, not class. Very, very important. We'll talk about this one in just a second. And then finally, the way we do compatibility, and this gets back to the loader. The loader is really important. The way we do compatibility is using some notion of policy. So these 4 tenets kind of were forged out of watching what worked and didn't work in COM, what worked and didn't work in MSMQ, what worked and didn't work in .NET Remoting and ASMX and blah, 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 blah. And so for us, over in the DSG at Microsoft, we use this service orientation idea in these 4 tenets. Boundaries are explicit, services are autonomous, share schema, not class, and policy-based compatibility. These 4 tenets, to us, look to be like reasonable litmus tests to have something that will survive the immune system that is this program. So, we know there's only one program, and we know it's very, very hard to change. What else do we know?
Objective interpretation is an oxymoron. Think about that for just a second. And to illustrate that, I want to play a little game. Shall we play a game?
Let's play a game, Doug.
All right. This is going to sound a little interesting. All right, here's the game. Everyone close your eyes. Just for a second, bear with me. You're saying, who's the bald guy telling me to close my eyes? I'm sorry. But close your eyes for just a second. I'm going to say one word, and I want you...
Doug, he's got his eyes open.
Stop, please, I asked.
Close.
Okay, just close your eyes for a second. I'm going to say one word, and I want you to think about the visual image that you hear, or not hear, but rather see when I say that word. The word is car. The word is car. All right, everyone open your eyes. Who saw a Corvette? Couple people. Who saw a Porsche? Oh, lots of people saw a Porsche. Who saw an Audi? You want to see an Audi? Couple people. Who saw their own car? Ah. There's a very important lesson in that exercise that we've just done. What does car mean? It means Audi. Does it mean Porsche? Does it mean the car you have in your garage? There is no such thing as objectivity when we talk about the exercise of interpretation. And guess what? Programming and building distributed systems is all about interpretation. And the failure of most systems have been because they have assumed objectivity in the interpretation. Web services, WS Star standards, WYSI, Indigo, ASMX. The work that we do at the Distributed Systems Group is all about acknowledging the exercise we just did. There are n numbers of definitions for the word car. There are n number of definitions for the word purchase order. What does transaction mean? What does that mean? How many times have you done a design exercise where you've sat down with the business folks, or you've sat down with your customer, or you've sat down with consultants, and they've said the word, oh, I want it to be transacted. Come to find out, you build a transacted system, you go and you talk to them, and they're like, that's not what I wanted. We all know, if we're successful in software, that the number one thing you nail down is shared semantics and shared understanding as best you can. The downside is that's very hard to do, if not impossible. Web services, service orientation, the work that we do acknowledges this fact. Objective interpretation is an oxymoron. One of the key things to bear in mind if you look at the technology space that we work on is a lot of people think when they go up to a web service and they get a WSDL and they get some schema, they say to themselves, that's how I communicate with that service. This is the contract that service fulfills, and that's certainly true. But then they take that schema and they build a programming model with that. They grab the schema and they run over and they take a tool and they go, blah, 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 I got a class. And then they program against it. That's great, that's a convenience, that's wonderful, but it's a lie. Code generators based on schema are lying to you. All they are is they're taking some description of data out in the cloud someplace and trying to give you a programming model. That's great. My team writes those sorts of features, but they're lies. They're crutches. The truth is, any schema, there are n number of schemas that a given instance document can validate against. That's a profound statement. Think about that for a moment. I take any XML instance document. Now see, this is what happens when you have Don Box on the stage. He's going to build a whole operating system right here. Mem copy, blit. Look at this. Here's a purchase order with an amount inside of it. What's the schema for this? Oh, look what Don's doing. Is that the schema for this? What's the schema? Here's an even more important question. Which schema language? XSD, RelaxNG, C#, BNF? What's the right answer? Here's one. Don has provided a reasonable schema for you. Is that the only one? What if I wanted amount to be a string? That'll work too, right? Here's the key thing. Just because someone publishes a contract, that doesn't mean that's the only contract for that particular piece of data. And it's very important that you grok that. It's very important that you understand the tools that generate programming model from schema are, in essence, as I've said, lies. And look what Don is showing you. He's showing you again and again and again different schemas for that particular instance document.
This is huge.
It's tremendous.
Right.
Otherwise we wouldn't say it.
You're right. Whatever Doug. If you think about the way the CLR works, right? The CLR is a really good petri dish for looking at OO thinking, right? The CLR is really a runtime environment that it supports many programming paradigms, many of them actually quite well. Certainly people thought a lot about object orientation. And one of the most interesting dichotomies here between the world we live in our team and the world of the second floor of our building, which is where the CLR gets built, is in that world, a given value in memory, right? If I look at the CLR, right, there's a bunch of values and objects. There's a method called getType.
GetType's an interesting method.
GetType is a very interesting method, and what's important to note is it returns a singleton, right? The arity of the result of getType is 1. It's not 0, it's not question mark, it's not star, it's 1. Because there's a strong binding to instance, to type inside the runtime we happen to work with. In contrast, in the world of XML, there is no such strong binding. In fact, the arity is star, right? If I could do getType on a piece of XML, the maddening thing and yet the beautiful thing is the fact that there's any number of valid schemas. There's any number of valid schemas that describe that instance. And really the way we do this data-oriented, message-oriented world of service orientation is to say, look, I have my notion of what the schema looks like and the technology I'm going to use to do it. Doug has his. And as long as the schemas that we use have some notion of structural compatibility, that is, as long as things line up, it might be a good idea to make it work, right? And if you think about the fact that, again, services are autonomous, I don't get to redeploy the whole world, the program's running, the fact that I can use a technology that takes this into account turns out to be incredibly enabling. Because what happens is, I'm not relying on having the exact objective interpretation in Doug's program, part of the program, as I have in mine. Now, it's got to be similar, right? Don't get me wrong here. This is not, AI, it's all going to be magic, and, the skies will turn dark and we'll all be in bubbles, right? It's not like that. But what it is about is the fact that I can get my part of the program to work with Doug's part of the program without getting him to buy every assumption I made. And that's why we say objective interpretation is an oxymoron. There is no objective interpretation of this original XML that I drew up here. There are many interpretations. There is a notion of compatibility. And notice that because we use things like regular expressions and grammars, we can actually build tools to look at these grammars and determine whether the grammar that Doug is working with, his set of assumptions, is compatible with my set of assumptions. But the assumptions don't have to be identical. That's the observation, right? There are many interpretations, many of which are compatible, and that's all we need. Think of it as good enough compatibility. This is a radical departure from the way our object-oriented systems work. Now, there's another, I can feel people in the room just saying, oh my God, I'm going back to iDispatch, right? This is a throwback to the world where I have no assurances that the thing is going to work. So remember that when we talked about the 4 tenets, right, the third tenet was share schema, not class, right? At best, I'm going to share my schema, and he may change the schema. He may tighten it, that is, he may restrict it so that he accepts a subset of the messages I accept, or he may widen it and allow more messages, be more liberal. Right? The fourth tenet, though, is we determine compatibility based on policy. And this is, again, the departure from the way OO systems work. What we do in this world of service orientation is we have fairly loose contracts with respect to the message formats. We want them to be as liberal as possible because that's what allows us to have the thing be resilient in the face of, whatever change we can affect, which is always very minimal. But I do often want to be able to guarantee that there are some shared assumptions. So when Doug said car, it was okay that you all thought different things. But let me ask you a question. When Doug said, close your eyes and think about car, how many of you thought of your dog? Show of hands. Yes, I'm sure there's one smartass in the room who will do it. Thank you, smartass in the back row. We have a problem with him, right? I often need the ability to level set shared assumptions, but often those shared assumptions have nothing to do with the format on the wire. Those shared assumptions that I need to establish between Doug and my parts of the program often have to do with things that aren't even about the plumbing. They're about things like licensing. Before I allow Doug to ask my service to do work, I may want to make sure that his part of the program has paid the tax, has paid the tariff, that I'm going to get my taste, my tribute, so to speak, in this transaction. How am I going to do that? Well, it's not about the message. The message he sends me would look identical with or without this licensing agreement. But we need to establish the fact that we have the licensing agreement before I'm willing to allow him to do that. I may want to make sure, he may want to make sure before he talks to me, that yes, I'm willing to give you money, Don, but please don't share my email address with all of those nefarious characters who are going to send me mail about enlarging parts of my home. So before Doug allows his part of the program to communicate with mine, he may want some sort of an assertion that says, agree to the following privacy claims that say I will in no way share this information with any nefarious characters. And how are we going to do that? It's not about the message schemas. It's not about sharing schemas. And trying to conflate the way schemas work to capture that is a bad, bad place to be. We tried to do that with XML schema. Right? I worked on the XML schema working group. I came at it from an OO mindset. I apologize. I'm so sorry. Forgive me, please.
And the serialization team often tells Don, there's only one person who could have fixed this, and it's you.
Yeah, I know. Right? We tried to conflate this notion of having a grammar that we can use for validation and structural description with this nominal world where we associate global names with ideas. We tried to conflate them into a single language, and it was a mess. It's a real mess. RelaxNG is infinitely better because it makes no such attempt. It's just a grammar, and it's a good grammar, and it's great. All this other stuff we let other technologies do. And in the world of web services, and this whole service-oriented world, the technology we use for this nominal shared assumptions is this thing called WS policy. And WS policy lets us assign a globally unique, stable name to an idea. That's all it is. If you've used Java, if you've used C#, if you've used VB.NET, there's an analog in your daily programming experience that goes hand in hand with this idea. It's called a marker interface. I'm sure many of you have used marker interfaces. What's a marker interface? It's an interface with no methods. It's an interface that simply says, yes, I believe in car. And because it's got a globally unique name, I can key it into human-readable documentation, I can key it into Google, and go see what the world thinks car means. I can go gather information about it. Right? It's a hook into human-readable documentation. So the big thing we're doing, one of the things we're doing in service orientation is separating out the structural descriptions of what the messages look like, which we do based on grammars, from this nominal typing system, which is basically like marker interfaces, except we use something a little bit more elaborate called WS policy. So, good contracts make good neighbors. When I bought my first home, one of the property lines was just dirt with some slight vegetation on it. And I had a problem because the welcoming committee, when I moved into the neighborhood, was a fellow who worked for the airlines who lived on the adjacent property who said, you know, I was in a fight with the previous owner about where the property line actually is, and I think we should sit down sometime and try and come to an agreement. And I lived in that house for 2 years. And every time I drove by his house, I cringed. Every time he would wave to me, I was afraid he would want to come over again and discuss what are the rules for where the boundary between his property and my property was. One of the things we wind up doing is building fences between our homes so that we have an understanding of where yours begins and mine ends, right? Having that actually isn't so much about separating, it's about bringing us together. That neighbor, he may have been a great guy. He may have had many shared interests. He may have loved calm. I'll never know. There's a human being that I went my entire life without ever having a real conversation with because I didn't have a fence. Had I had a fence, the property line would have been clear, and there would have been no animosity, there would have been no fear or anxiety over the interactions with that person, and we would have found out that there were many things we shared. It would have been a wonderful relationship. Who knows, I would have named my child after him. It could have gone anywhere, right? But it didn't. Having these boundaries is important. And a lot of the service-oriented technologies that we work with are about defining the lines between the programs. And it's interesting to think about, is a fence good enough? Is having a good contract between your program and my program sufficient? Does that mean I'm done? Does that mean that, well, I wrote the WSDL, I wrote the IDL, I wrote the whatever the XML format we're going to use tomorrow is to describe the interactions? Is that sufficient? Well, certainly it isn't today. It isn't today. I'm not able to, for example, expect my fence to keep my dogs barking from interrupting my neighbors. Turns out I have to take explicit acts. I have to actually think, not only do I have a good fence, but I also have to behave a certain way. The assumptions I make about my neighborhood are really, really important. When we introduce technologies into these systems, sometimes they make our life better, right? You're going to see a lot of new technologies rolled out here at TechEd. I got news for you, right? You thought those introductions in Steve's keynote, that's just the beginning. We have a whole line of boxes we want to shove onto some trucks and send out to your place of business. And we'd like to get paid for it too, but that's another story. How many of those technologies are going to make your life better? We hope a lot of them, but I got news for you. Some of them may not. Some of them may not help. Some of them may make it worse. A lot of times, adding more technology to the mix isn't going to help us at all. In fact, it's going to make it worse. So, having a technology that is unobtrusive is important. And so, the philosophy we have taken is that at a global scope, to get our programs to work globally, introduce as little technology as possible. Back in the 90s, we tried to get the world to flip over to Corba. It failed. We tried to get the world to flip over to DCOM. It failed. A couple things got lucky. A couple things became viral and took over the world. HTTP and XML. Got lucky. They caught a break. That may be as good as we'll get. We might get more, but those aren't going away. And taking advantage of them is a very, very good idea. So, having a platform through which we can do this integration with as little new technology as possible is very, very important. Otherwise, we're not going to get it to work. Does that mean we stop? Does that mean we stop trying to innovate? No. What it means is we're moving to a world where we integrate based on protocols. Right? The fact that everybody and his brother is shipping a WS Star spec nowadays speaks to the fact that people have come to the realization that the Java vision or the CLR vision is at best a silo. It's never going to take over the world. But protocols have the opportunity to get a network effect and actually run all over the place, have broad, broad impact. So what you're seeing happening within Microsoft as well as within other vendors is that we're focusing on the protocols as the integration substrate, that I'll never get IBM to agree that the CLR is the only way to program. It's not going to happen. At best, we might get most of Microsoft to think the CLR is good. There's still people at Microsoft who don't write managed code, right? And there are people who say this managed code thing will blow over. Just like there were people who said this whole user mode and virtual memory thing will blow over as well, right? All we can agree on is protocols. All of the innovations we do are basically making our neighborhood better. So, if I look at the innovations we've done in the past, and I look at the innovations we're doing in the future, how do I know how to judge it? How much COM is needed to make this whole program work? How much COM do we actually need? Well, a more interesting question is, how much unmanaged code do we need? Several people asked in the Q&A session, what's the future of COM? What's the future of the COM developer? Well, it's a very interesting question, but it's related very closely to what's the future of the unmanaged code developer. There are many, many, many pieces of the program in the future that will be written in unmanaged code. C++, VB6, VBA, right? It's not by accident that Office 2003, the primary way you build solutions inside of Office 2003 out of the box at least, is using unmanaged code, which means you're using, guess what? You're using COM. As long as there is unmanaged code, we will need COM. Now, Transitioning to managed code, everyone knows why it's good, everyone knows why they can't do it overnight. It's going to take decades to get all new code written that way. But as the amount of unmanaged code decreases, the amount of COM that is needed decreases. Does that mean we're done with COM? Does that mean that we say, okay, fine, we've reached a point where there's no more, where we've realized that there's a half-life and that there's not going to be any more unmanaged code, therefore let's kill COM? No, quite the opposite. I mean, we got to keep this program, at Microsoft, we have to keep this part of the program running, our parts. And so what we do is we try to make sure that there's a continuity for that code going into this protocol-based world. So what are we doing? Well, we took a stab at it with .NET V1. With .NET V1, we tried to make COM a good citizen in this new service-oriented world. Right? COM plus 1.5 had the facility where I could say, expose my server application as a web service. We also had this ability to bind pieces of .NET remoting technology into proxies, and it was an okay attempt. As a first pass, it was completely respectable. Going forward, what are we doing? Well, more importantly, what we're doing is we're taking our investments in Indigo, which is a managed runtime for doing all of this crazy protocol stuff, and making sure that that has first-class access from unmanaged code, right? I want the ability to take my Excel VBA 6 script and talk to my Indigo services. I want the ability to take my VBA script in Word and go off and talk to Amazon or go talk to Google. And so what we're doing is with the Indigo release of our technology, you'll have the ability to not only expose your COM Plus services using Indigo, but we'll have very, very, very close integration with COM to the point where we're actually hacking on OLE32 to make sure that we can load the Indigo runtime and give you the same level of service in unmanaged code that you get with managed code. And the way we're able to do that is because we have a COM. Because COM had good ideas. It had explicit boundaries. It had rich metadata. We're able to take advantage of those things and use them to see this new world. So COM's really important. We're very dedicated to keeping it going. We have a lot of investments going forward. How much remoting does a program need?
Well, since my team owns remoting, I can maybe address that. Or actually, our whole team owns remoting. But if Matt Tavis is in the audience, he is the PM for remoting, wonderful person, and I want to talk about the technology that he owns. I think one of the key things that Don is highlighting here is that because we understand there's one program, and because we know we can only replace bits of it in a very, very, very incremental fashion, if at all, and that's the key thing, if at all. A really great question is, how long will COM be around? Well, the likely answer is forever. And how you can tell that's true is because of the work that Don is doing and the work that our team is doing and the work that the V1.NET framework did in order to incorporate COM, as Don was saying. Likewise, remoting is already out there. Many of you have adopted remoting. And there is a place for remoting in new systems. Certainly remoting is going to be a technology that folks will need to utilize for certain targeted scenarios. But just as we're doing a great job trying to make Indigo and COM work together, or V1 of the .NET Framework and COM, likewise there will be a great story for customers that utilize remoting moving forward. These are the key bits, yet again, that are driven by the fact that there's one program. And so if you are going to have a new technology come in that allows people to write pieces for this one program, you also need to have a very mature strategy about realizing, number one, you can't walk up to your customer and say, 6 months ago we told you to use this technology, now we've had a great mind, I want to say mind fart, but that's not what it is. We had this great acknowledgement of the technology we should be using. We want you to totally change. Sorry we didn't tell you about it 6 months ago. And many folks that we've talked to have felt that way about remoting. People have said, hey, you told us to utilize this technology, we're doing that, and then you come down and you tell us not to use that technology. I think a right way of looking at that is that you need to be very, very mature, that the program is still evolving, the technologies that we use to build that program are still evolving, and we're still learning. Anyone who tells you that the technology is going to solve your problem today and you'll never need to revisit that is lying to you. We need to be mature about this. So remoting is a technology that's very, very useful for cross-app domain scenarios. It's also very, very useful for some integration scenarios. And one of Don's favorite features in the entire CLR is in the remoting stack. It's called Transparent Real Proxy and Stack Builder Sync. And in fact, core pieces of Indigo are being built on that particular piece of technology.
Fundamentally, remoting is a feature of the CLR. It is of the CLR. And if you're within the CLR, it's a feature you should really strongly consider using. In fact, there are places where you can't escape it. Right? If you ever do
cross-app domain,
if you just grab a reference to an app domain and start doing things to the app domain, in all likelihood you're going through remoting, especially if it's not your app domain. So, to the degree it's part of the CLR, it'll always be with us. It's probably not, again, expecting the whole world to have the CLR is a big assumption. And so it's probably not the spine of the way we will plumb the next generation internet, which we talk about every generation. How much enterprise services does the program need? A fair amount. Remoting is an interesting situation. Remoting was like a lot of technology, right? Remoting never got productized the way a lot of other technologies do, right? There's no tool support for it other than the text wizard, right? There's a text wizard in Visual Studio that you can type into and get your remoting code to work, right? Enterprise services turns out to have a fair amount of value for a large number of customers. People say, why do I need to use remoting? I want to use remoting because it's highly performant. Well, guess what? If I've got code in this app domain, and you've got code in that other app domain, and it's on a different process or a different machine, what's the fastest way to get from here to there?
I know.
What is it, Doug?
I think it may be enterprise services, DCOM.
It's DCOM, right? DCOM is a faster protocol than the binary formatter with the TCP transport that people seem to know and love. Oh, and by the way, it's got another really interesting feature. I can secure it, right? This .NET remoting being faster, it's like having a car that goes really fast with no doors or no seat belts.
And no
right?
floor, no floorboard. You can fall right out.
No floorboard, yes. Right? We spent a lot of energy making DCOM fast. We spent a lot of energy making DCOM secure. And some of it was very public, right? So believe me, we've taken our lumps for that deservedly. ES is the easiest way to take advantage of that. Now, you need to use ES to use DCOM, right? Those of you who love hacking the registry, a little bit of regasm and a little bit of registry hacking, and you can write a DCOM server that gets activated using the old classic scum. Don't do it. Just give in. Enterprise services is a completely sound technology choice when you need fast cross-machine or fast cross-process communication, and it's all going to be .NET. And it's all going to be your code. You have maybe not the 2 cubicle rule, but you've got a much more controlled deployment scenario where you don't have to worry about many, many versions of that code living out in the wild.
So one of the things I want to really touch on very quickly, many times customers come up and say, we want to use remoting, as Don was saying, for performance reasons, and that's the reason we don't want to utilize ASMX. One of the key things to get across in your mental model of these different technologies is don't confuse implementation detail with model. The .NET remoting model does not acknowledge the fact that there's one program. It just doesn't. It's still based in a pre-programmed sort of mindset because it makes certain assumptions about having a homogeneous environment. Just because remoting may seem, in terms of implementation detail, to be faster than ASMX doesn't mean that it's the right model for you. You need to think long term. Remember, once you put something out there, it's part of the program, and it's very hard to change it. So model considerations are very important. Don't confuse the fact that one particular implementation detail isn't exactly what you need. The binary formatter, in some instances, is faster than what you can utilize with the XML serializer and ASMX. But think really hard about that. Is that really the top order bit? Is that really the most important thing over the next 1 year, 2 years, 3 years? Think hard and think long term. Because the moment you commit to shipping your product based upon a particular implementation decision, you may have made the wrong decision. And much of what Don talks about here is think about the model, and the implementation can grow over time. ASMX will be faster than .NET remoting. We're working to make ASMX and Indigo certainly, just as fast as what you would get with DCOM. Those are implementation details. It's the model that's important.
Yes. 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 It's frustrating that .NET remoting is faster than ASMX. ASMX is closer to the truth. ASMX is closer to where we're going, where we've watched successes and failures guide us. ASMX is really good. But there's faster stuff out there, right? But at some point, if you get the model right, the implementation catches up, right? If you think, it's hard to imagine that, guys like Chris Sells, really low-level C++ heads now love the garbage collector, now love managed code, right? It took a lot of C++ programmers a long time to let go of their assumptions about how code should run. But what happens is, in time, the implementation catches up to the right model. And betting on the model is a really important thing. To that degree, how much ASMX are we going to have? How much do we have now? Lots. How much are we going to have in the future? Even more. ASMX is really, it's where you should be. When in doubt, it's ASMX. If you're using our shipping platform, and you're looking at all of the many technologies we ship, if you can make it work with ASMX, do it. If the ASMX performance is good enough, it's good enough. And if it means you buy 3 more machines, that probably is a reasonable investment, right? Throwing hardware at the problem isn't always the wrong solution. How many WS star protocols does the program need? Less. Less. The more we have, the less value any of them have. The whole idea is to have a common way to exchange messages, a common way to secure messages, and a common way to make sure the message got there. We have a common message format. It's called SOAP and XML. Is it perfect? No. Is it good enough? Yes. And going back to a question about verbosity, it's the right model. It's not as fast as other things you can do today. Anyone who's used .NET remoting and has flipped on the SOAP formatter versus the binary formatter can attest to the fact that it's not as fast. But the model is right. The model is more than good enough, and that's the model the world's investing in. And the implementation will catch up to the model. It always does, to the point where perf will not be an issue. How will we do it? All kinds of crazy things. First off, we can make the XML parsers go faster. We've got a lot of work to do there, right? There's all kinds of improvements we're doing in WIDBE and beyond WIDBE and making just the XML plumbing that we've already got go a heck of a lot faster. But if it turns out that Doug and I are working together, our parts of the program are communicating, and we figure out, hey, we're both running a common platform, we have this idea called negotiate up. Because one of the policy assertions I can tell him is, I'm running on Indigo version 1.x. He can say, I'm running on Indigo version 1.x. And at that point, we flip over and use a SOAP-compatible, XML InfoSec-compatible wire format that doesn't suffer the verbosity, but has the same characteristics, has the same versioning characteristics, has the same processing model.
Key point there is XML is not text. It's just not text. The XML info set is agnostic in terms of encoding. And it's the XML data model that's very, very important here, not text.
Yes. How much WSI does the world need? Well, to the degree SOAP is insufficient, we have to do these other things. It would be great if SOAP was enough. But it turns out that if I have a message that's sent to Doug, and Doug's going to send it to somebody else, we can no longer rely on transport level security, because I don't have an end-to-end connection between me and the person Doug is going to send the message to on my behalf. And that person I send the message to on my behalf, Doug sends it to on my behalf, wants to know it's in fact from me. So for that, we need WS security. And WS security really implies we also need WS trust and WS secure conversation, if we care about performance. But those 3 protocols together, WSSec, WS trust, WS secure conversation, collectively give me the SSL style or the SSPI style guarantees on an end-to-end basis independent of transport. To the degree I need that, I need WSI. If I'm in scenarios where I'm doing multi-hop message processing, I'm going to need to use WS Security. I'm going to need to use WS Trust. I'm going to want to use WS Secure Conversation. Guess what? If you want those things today, WSI snaps into ASMX and takes your ASMX investment and says, okay, great. Now we can do that not only just to Doug, but Doug can take that piece of the message and send it to someone else. And I don't lose the security guarantees I would get with a normal transport level connection. Similarly, if I'm sending it to Doug and Doug sends me a response, I know he got it. But if Doug sends it to someone else, how do I know that the ultimate receiver, the ultimate person who's going to be processing the message, got it? Again, I need end-to-end acknowledgments. That's what we have WS Reliable Messaging for. Subsequent versions of this technology will support WSRM, right? And that's good. I need those things. If I have these multi-hop scenarios, that's the primary motivator, right? If I'm in a simple scenario where it's just me and Doug, and he in no way purports to take this message and send it to someone else, then I may not need WSI, I may not need WS Security, I may not need any of those things. Transport level security might be good enough. Transport level reliability may be good enough. But sometimes it's not, and when it's not, that's when I need WSI. So, before we wrap up, we took some questions. How does WSI 2 fit into the Indigo direction? It's really simple. It gives you a chance to use the protocols now. Indigo's sometime in the future. I don't know when Indigo's going to ship. It's too far out for my taste. I wish we could ship tomorrow. I thought the build we had yesterday was perfect. Why we don't just ship that thing, I'll never know. You know, we're going to go through...
I can tell you why.
Yeah, yeah, I know. WSI takes your ASMX investment and keeps you in the game as we do this protocol work. If you're not tracking this protocol work, WSI probably isn't as important. It does actually have some benefits, but it's not the key thing. Over time, Indigo will be the primary technology we use for those protocols. And at some point, there will be a version of WSI that interops, right? But WSI is really to take your ASMX investments now and get you in the game with the protocols. What's the future of DIME? It's easy, MTOM. We did something called DIME. It was an experiment. We thought we were on the right track. And you know what bit us? Security. We put a few features in DIME that were just impossible to secure well. So what we did was we got together with some partner companies and did this thing called PASWA, which became MTOM. MTOM is the way we will do interleaved binary and XML in Indigo and on other Microsoft technologies. WS Security supports many kinds of token formats. One of them is SAML. Of course, people will be putting SAML tokens in there, just like they'll be putting in XRML tokens or Kerberos tokens or username password tokens, right? The idea that we can have a single token format that will rule them all is a beautiful vision, but I don't know that we're going to get there, and I don't think anybody else does either.
And it's antithetical to the program.
Yeah, and it's antithetical to the program. Scoping of WSI and interop. We do bake-offs with WSI. We take it to these workshops. We get other vendors in the room, and we try and make our stuff work. And we've had pretty good luck with it. I do not know what the exact status of WSI 2.0, which got released this week, is with respect to interop with existing products. I suggest you find the non-retarded Becky Diaz and consult her. I'm sure she has lots of information on exact details. How do I do SOAP from a Windows service? It's pretty easy. You take ASMX and you build an HTTP worker request and you go. ASMX can be hosted anywhere you want if you're willing to write some code. If you're not willing to write some code, you have a challenge. It means we could just ship you another version of the operating system. I'm sorry, right? We don't have a great story for doing SOAP inside of an NT service. The best way to do it pragmatically is to put an ASMX facade in front of your NT service and call into the NT service using ES or using .NET remoting. For now, that's the best way to go. Going forward, we'll be doing a much better job here. COM+ replacement. COM+, we obviously brought into the managed world with enterprise services. Most of those ideas have influenced Indigo, and Indigo will support most of those ideas. But your ES investment is, you know, we're preserving it. It's going to keep working. what happens is the ideas of deployment, interception, managed services like transactions and synchronization, all of those things are being brought forward in the world of Indigo.
And in fact, one of the easiest upgrade paths to Indigo is actually utilizing enterprise services. Many of the semantics, if not all the semantics, there's a direct correlation in the programming model with the semantics that are inside of ES. And Steve Schwartz likes to say, if you're an enterprise services developer, you have the best experience moving forward into Indigo.
Yes. Yeah, absolutely. Verbosity will negotiate up. Other people will negotiate up. Exactly how that shakes out remains to be seen. The industry has had a very hard time getting binary protocols that allow user definition, right? That's really the point. Binary protocols like TCP that are fixed, we can interop on because it's a closed spec. The industry has not had a lot of success with binary protocols that allow arbitrary user-defined structures to come along. We think XML 1.0, the text format, is the way we're going to do interop, and the way we're going to do high-performance communications will be through some negotiate-up system. How do we find services? We tried this thing called UDDI, right? How many of you guys use UDDI? A few people. UDDI makes some people very happy. Good. It's going to continue to make you happy. However, we've heard from our customers that they want more. That they want a more flexible model for describing things that doesn't require me to understand what a T model is, which is a wonderful thing once you grok it, but until you grok it's a little bit opaque. They want something that's more suitable for use in devices, because I want to discover the programs running inside of my devices as well as on my normal computers. So if you look at what we did with WS Discovery, that's a very good indication of where we're headed in terms of how we find services. And WS Discovery is a fairly small spec, fairly easy to understand, and you can actually implement it modular to UDP support in pretty much anybody's web service stack. Will we still need plumbers to do security? For a while, yeah. WSI makes it easier, but it does definitely, if things go wrong, you'll need a plumber, right?
Our personal goal on the Indigo team, Don and I recently did an interview, and they asked us what our favorite protocols were. And our response generally was, we have not done our job with Indigo if people have to understand the protocols. People can want to understand those protocols, they can want to embrace them, maybe build implementations of them, but your common developer that writes enterprise applications needs to be solving his or her business problems, not worrying about the dirt and grime of a particular protocol. Solve your business problem. That's what Indigo is all about, adding value and not worrying about the protocols. A protocol is a means to an end. It is not the end itself.
And unfortunately, no matter how good a job WSI does at insulating you from the details of the protocol, while we're in this phase where people are still working out the kinks in the protocols, when things go wrong, it's unfortunate. You'll be reading the WS security spec. When things go right, though, at least we're to a point now, right? Where we started, you had to be a plumber to even get it to work when things went right. At least now, plumbing knowledge is only needed when things go wrong.
MSMQ and COM, really quickly, we have a technology called queued components. We also have a managed technology called system.messaging, both of which are wonderful, great technologies. Use them where appropriate.
Yeah, and if you go to Richard Turner's talk, he'll talk more about what we're doing with MSMQ.
And there's Richard in the back.
Forward.
He's biting his nails in anticipation.
Yes. Of course. How do I connect things with messages? Migration path. Just keep writing your code, right? Don't do anything crazy. If you're doing something that was hard to figure out, maybe it was hard to figure out for a reason, right? If you stay the course of what seems reasonable with these technologies, as soon as you find yourself writing a SOAP extension in ASMX, realize you've gone outside of the safety zone. As soon as you start writing a message sync in .NET Remoting, you're probably going outside the safety zone. As long as you use the technologies as they were intended to be used, just use them. Enjoy them. They're all pretty good. They're all kind of easy to use, actually. Going forward, we keep them all working, but if you go outside the safety zone and do things like writing message syncs and do things like writing SOAP extensions, that piece of code is going to get to be rewritten. And I'm so sorry, I wish we could do a better job.
So much of these other questions we can address either in Richard Turner's talk, or you can come up at the conclusion of this talk, and we'd be more than happy to answer those questions for you. But we do want to take an opportunity to wrap up.
Yes. So, you're going to see the same stuff over and over again. If you look at all these technologies, they're all within 40% of one another. And when you look at Indigo, guess what? It's going to be within 40% of these things. Right? There aren't that many new ideas. Really what we're trying to do is get the majority of developers to do the stuff that seems to work and try and keep developers from doing stuff that doesn't work as well. And the fact that these ideas look similar is not by accident, right? At the end of the day, I need the ability to load code. We've got N ways of doing it. I need the ability to find that code. We have N ways of doing it. And I need the ability to get my code to talk to your code. And there's only so many ways to skin that cat. This notion of service orientation with the 4 tenets seems to me at least, to be a reasonable way to think about how to build these systems in a way where you can move on and actually think about problem domain instead of fighting plumbing. And fighting plumbing is a bad place to be. Bad place to be. So, Doug, would you like to say goodbye?
Well, thanks for coming out. The key takeaway here, I just want to close really quickly, is think about model versus implementation, and think about the fact that there is only one program, and allow those two facts to guide the way that you utilize our technology and your approach to talking with customers, to architecting systems for customers. Because it makes it very, very evident and very, very clear about what technology you should be using. And guess what? It's going to change in 5 years, and it's going to change in 10 years, and it's going to change in 15 years. So you need to be flexible, and you need to be mature about it. And we thank you for coming out.